I'm Edward.
And I'm Calista, and we are from SPHSC, and today we will be presenting BaP, a water purifier made out of banana waste.
Due to Indonesia becoming even more industrialized, a lot of the rivers are getting polluted. In this study, the purification of water effect in banana peels was studied through the manipulation of increasing the nitric acid concentration mixed in the banana waste. Our study can be used to better remove copper ions from water. Youtefa Bay in Jayapura City, Papua, is an example of a river that is polluted. It has been found to contain a maximum of 79.8 milligrams of copper in its mangroves and river. The communities and the ecosystem of Indonesia's rivers has become threatened because of this. Through our own experiment and statistics, we calculated that Indonesia produces 3.1 million tons of banana peels yearly. Research question 1. How can the mixture of banana peels and nitric acid be used to purify water? 2. How does the different concentration of nitric acid in banana peels affect the removal of copper sulfate from water, thus copper ions? The objectives of this study aims to reduce copper contamination in water out of a mixture of banana peels and nitric acid. We will investigate the effects of utilizing the chemical compounds nitric acid towards the removal of copper ions.
Several research indicates that bananas are able to purify water due to the compounds found in them, such as nitrogen, sulfur, and organic compounds such as carboxylic acids. There are also acids that may enhance the purification process. We hypothesize that if the concentration of nitric acid increases, the concentration of CO2 plus in the water sample will decrease. The three theories that support this hypothesis are the enhancement of the biosorption process in these banana peels, enhancement of metal binding between substances, and the HNO3's own ability to dissolve CuSO4. The research conducted was quantitative and had a total of 25 trials. The baked banana peels were processed in a food processor for 5 minutes at speed 3 and mixed together in a 1:10 ratio of nitric acid. It is then dried for 24 hours in 115 degrees Celsius. 2 grams of specific banana peel compound and 200 milliliters of CuSO4 solution was mixed together with a magnetic stirrer for 10 minutes. The data collected was from titration results to determine the amount of copper ions removed from the water. The concentration of copper can be found in titration as the reaction involving cupric ion and iodide takes place quantitatively, since the cuprous ion formed as a result of the reduction is removed from the solution as a precipitate of cuprous iodide. In this specific experiment, 10 milliliters of treated copper sulfate will be mixed with 10 milliliters of 0.5 m potassium iodide. Afterward, the analyte solution was titrated with Na2S2O3. The following graph shows the different concentrations of CO2 plus in the CuSO4 treated samples. It can be observed that the data shows a negative correlation between the concentration of HNO3 and the concentration of CO2 plus found. This is proven as the trend line above the equation is y equals to negative 0.0054x plus 0.0163. The one sample Kolmogorov-Smirnov test on the SPSS software was used. If the value of the test is greater than 0.05, the data is considered to be unrepresentative and not have a normal distribution, while a value of less than 0.05 will show that the data is representative and can be trusted to not be greatly influenced by outliers. As the Kolmogorov-Smirnov test shows that the significant two-tailed result is 0.007, which is less than 0.05, it supports the second experimental hypothesis. There is correlation between the concentration of HNO3 in the banana peel purifier and its ability to remove copper ions in water. It is therefore implied that the data produced can be trusted to show a correlation between the concentration of HNO3 and the concentration of CO2 plus that was found in the water.
For the strengths of this experiment, we can conclude that our study is fairly accurate, as shown by our study's significant two-tailed results of 0.007. According to the data previously mentioned, the banana peel purifier shows more potential when mixed with nitric acid, as shown by the negative correlation indicated by the table previously mentioned. For the weaknesses and improvements, more trials may be needed to ensure more data can be accounted for to overcome the fact that the range of dependent variables may be too small. A different acid, like chloramine, should be used, as nitric acid can potentially be toxic when ingested. For the conclusion, overall, the study aimed to find the effect of the additional acid on a banana's peel ability to purify water from copper. The study found that the banana peels were able to remove more copper from water, showing a strong correlation between the two variables. With more work, we believe that the concentration of nitric acid in banana peels has the potential to become an effective water purification method for copper ions.
Thank you for listening.